Hi students, now I am going to explain another 4 marks question from chemistry first year. This is the 18th question. State Graham's law of diffusion. 360 centimeter cube methane gas diffuses. Already this question I wrote here, you see here. State Graham's law of diffusion. Already I explained this question in my previous video, once you check that video. And here one problem is given based on that diffusion. We will do that problem. Now see, first we have to write definition of Graham's law of diffusion. This is R is inversely proportional to density, root density. This is the simply Graham's law of diffusion. So rate of R is the rate of diffusion. Rate of diffusion is inversely proportional to density of that gas. That means if you take two gases A and B, which gas has more rate of diffusion? The gas which has the lowest density, because inversely proportional density is less, rate of diffusion is more. That means density less means simply weight. Less weight has more rate of diffusion. What is rate of diffusion? Simply rate of diffusion means spreading of the gas in the volume, or the volume occupied. Suppose it occupied this much volume, this gas occupied this much volume in the same time. That means if you take 1 minute, that means per 1 minute A gas occupy this volume, B gas occupy this much of volume per 1 minute. That means it has the more rate of diffusion. It has less rate of diffusion. That means rate of diffusion is the volume occupied by the gas in particular time. That is the definition for rate of diffusion. Okay, now once again I am telling, the volume occupied by the gas in particular time is called rate of diffusion. That depends on the density, and density means it depends on the weight. So from this I am writing, and it depends on the molar mass also, simply, and that means molecular weight. The gas which have the less molecular weight, molar mass, has more diffusion, more rate of diffusion. The gas which has the more molar mass, it has the less rate of diffusion. Simply this is the Graham's law of diffusion formula. From this I am writing another formula. You see, R is proportional to 1 by root m. Here m is the molecular mass or molecular weight. Molecular mass or molecular weight are both same. M is the molecular mass of that gases, because less molecular weight, suppose gas has less molecular weight, it has more rate of diffusion. Suppose gas has more molecular weight, it has the less rate of diffusion. Okay, from this you can write R1 by R2. If you take two gases, R1 by R2, R1 is the rate of diffusion of gas 1, rate of diffusion of gas 2, equal to, from this I am writing here root of, here m it is in the denominator na, so R2, for R2 m2 comes numerator, m1 comes in denominator. This is the formula. r1 by r2 is equal to root of m2 by m1. So already I explained definition. From that definition, how we can write r1 equal to volume occupied by the gas particular time t1. In the same way, r2 equal to v2 by t2. So r1 by r2 means how much? r1 by r2 equal to, r1 means v1 by t1, by, I am writing by like this, by r2 means v2 by t2. This I am writing here, v1 by t1 into this t2 comes to numerator, t2 by v2. Okay, this is the r1 by r2 equal to r1 by r2. Here I wrote what is r1 by r2? Root of m2 by m1. Okay, na? I am okay. From this, what is v1? Just I substitute all these values. What is v1? 360 centimeter cube means volume. This is the volume. 360 v1 equal to 360. Here I am writing v1 equal to 360, v2 equal to 120. Here centimeter cube, and t1 equal to 10 minutes. 10 minutes na 15 minutes. 15 minutes. t2 equal to 10 minutes. Okay na? And here m1 also we know from this. Wait, from this m1 equal to, sorry, here v1 v2 t1 t2 I wrote these values from this question, and here m1 also. This is the 360 centimeter. 360 is the v1. So methane, we can write methane molecular weight, that is m1. CH4 na, CH4 means, here I am writing CH4 means, this is the 16. Carbon, for carbons 12, 4 hydrogens 16. 16 is the molecular weight. 16. All these values, if you substitute all these values in this equation, we can get the molar mass of unknown gas, that is second gas, that is m2. I am writing here. Let's see. v1 means 360 by t1 means 15 into t2 means 10, by v2 means 120 equal to root of m2, that we have to calculate unknown gas molecular mass, this is m2, by m1 means 16. From this we can calculate the value of m2. Okay, this is, wait, 0 0 cancel, and I will use calculator. Okay, 3 times here, $72. Here this is 6 times. Here 2 times. Here 2 times 2. So finally finally 2 equal to root of m2 by 16. If you square both sides, 4 m2 by 16. that is M2 equal to 16 into 4, 64. What is the unit? 64 grams. This is the molar mass of unknown gas. This is the answer. Okay, simply once again I am explaining. You see, if we know this formula which indicates the grams law of diffusion, from this we can write all these information. This is the density, it is in the denominator, so molecular weight also in the it is also in denominator. So from this I wrote this. So R is proportional to, here R is the rate of diffusion proportional to 1 by root m. I wrote from this. So from this formula I can write like this: R1 by R2 equal to root of M2 by M1. And from the definition, what I told definition, what I have given explanation for the rate of diffusion, the volume occupied by the gas particular time, that is the rate of diffusion. So R1 equal to rate of diffusion, R1 equal to V1 by T1. From the definition I wrote this. Okay, like that R2 equal to V2 by T2. From these values I wrote this: R1 by R2 equal to V1 by T1 by V2 by D2. From this we can write like this: V1 by T1 into T2 by V2. This is equal to R1 by R2. But we know what is R1 by R2, root M2 by M1. That I have written here. From this, all these values which I have given in this question, substitute in this formula, and finally we can calculate the rate of diffusion of the unknown gas. That is 64 grams.